Hey fellas, we're going to continue on this factoring polynomials thing. This time we're going to talk about specifically quadratics. Okay, so we're going to talk about quadratics, which is this basic formula, right? A quadratic polynomial is this basic trinomial, ax squared plus bx plus c. Okay, so if we're going to factor this ax squared plus bx plus c, you guys are probably familiar with this, not very much with these variables, but I'll kind of derive where you probably came up with what you already know about factoring quadratics, okay? So if we assume that ax squared plus bx plus c factors to the quantity of px plus q times rx plus s. And I'm going to expand this and try to figure out what a, b, and c are equal to in terms of p, q, r, and s. Okay, so we need to do our foiling. All right, to get started. Okay, we're going to FOIL all this stuff and expand it. So we'll expand it to PRX squared plus PSX plus RQX plus SQ. Okay, those are our four terms. Now we can combine these two in the middle here, okay, because they both have an x in them. So in order to combine those, right, the PRX squared stays the way it is. If we combine these, that's going to be parentheses PS plus RQ times x and plus SQ at the end. Okay, so hopefully you recognize that if you bring this down, right, these look very, very similar. And in the same order, we've just got different variables. So we can split this up, and we should find that A is equal to P times R. Okay, B is equal to PS plus RQ, and C is equal to SQ. Okay? So, when you guys probably got familiar with this stuff, I don't know when, but at some point, you probably didn't have an A very often. Okay, so this A is technically going to be split up into the two numbers in front of the X. Okay, and the way you come up with this P and your R is by knowing that those two numbers have to multiply to be your A. Okay, and then the way you get your C, you guys probably know this when you're trying to factor something like this. The way you get your S and your Q is by knowing that these two numbers have to multiply together to equal C. Okay, and lastly, to get to figure out, to finalize this stuff, you should know that B, it comes from adding. Basically, you probably thought of it as S and Q, right? Adding those two up. But it's actually SP times, or SP plus RQ, because if you take into account the coefficients in front of the S. Okay, so another very simple way to put this is that in order to factor these, you want to find two numbers, S and Q, that multiply to equal C and add together to equal B. And I'll go through some examples for you. So some of these basic ones to get started. All right, we've got x squared minus 2x minus 8. Okay. Now what we have to do is we need to find two numbers. Right, in order to factor this, we've got the x and the x. We need to find two numbers that multiply to negative 8 and add to negative 2. Okay. Now one simple trick is to look at this the sign of the C. Right? If the sign is negative, then you know that you're going to have one positive number, one negative number, because they have to multiply to be a negative. If it is positive, then you know they're going to have the same sign. So that'll be helpful for us. So we know that we've got one minus and one plus here. Okay. Now, what are the numbers, the possible numbers that multiply to negative 8? Well, we know negative 1 and 8, or negative 8 and positive 1, 4 and 2, and the other way around, 2 and 4. Okay. But you want to pick the one that adds to negative 2. So if we pick minus 4 and plus 2, then these two numbers multiply to negative 8 and add to negative 2. So that would be the answer. X minus 4, x plus 2. Number 2 here. Y squared plus 3y plus 4. Okay. Same idea. We've got a y and we've got a y. Okay. Now, since this, we need two numbers that multiply to positive 4 and add to positive 3. Right, so because this is a positive sign, right? Once you see that's a positive sign, you know that they're going to be either both plus or both minus. So what you're going to look at next, once you find that that is a positive, is look to the second sign. If that's a positive, then obviously they're both going to be plus. If it's a negative, they're both going to be negative. Okay? So we know that since they're both positive, these are both going to be positive. All right? And what are the ways to multiply to 4? Well, 2 and 2 or 4 and 1. Do either of those add up to 3? No, neither of them do. So that means you can't do this problem. That means that this polynomial here is prime. So you would just write prime. Okay? There's no way to factor it. Now, r squared minus 7rs plus 12s squared. This is very, very similar. Right? A little bit higher level just because you've got two different variables in there. But it's really the same idea. Okay, so we're going to have an r at the beginning and an s at the end. You know that just by the way it's set up. R at the beginning, s at the end. Okay, there's no coefficient in front of r, so that means you're not going to have a coefficient in front of r in your answer. We need two numbers that are going to multiply to positive 12, so they got to be the same sign, and that are going to add to negative 7. All right, so they're going to multiply to positive 12, add to negative 7. Right, since the positive 12 is positive, that means they have to be the same sign. Since then negative 7 is negative, you know they're both going to be negative. So minus, minus. And now you got to find out what's two numbers that multiply to 12 and add to negative 7. Well, you know it could be 12 and 1, 6 and 2, 3 and 4. The one that works for us is 3 and 4. So it'd be r minus 3s and r minus 4s. All right, getting into the more difficult ones with an a term bigger than 1. So it's 2m squared minus m minus 1. All right, this is where it gets a little bit more complicated because now you know you're going to have a 2m, and the second one's going to be m. All right, so now when we try to figure out multiplying to negative 1 and adding to negative 1 as well, the problem is now you have to take into account that you're multiplying this 2 involved in the adding portion. So the 2 is part of the adding portion. So the 2 goes into the adding portion. It does not have anything to do with multiplying to negative 1. Okay. Luckily we have small numbers here, so there's only one set of numbers that multiplies to negative 1. It's 1 and negative 1. All right, but we have to figure out which is the right way to put it. Okay, so you have to think about it this way. The 2 has to come into account when multiplying, right? Because you've got like the outside portion of the foiling. Okay, so your negative 1 has to go in the second one, and the positive one goes in the first one. Now let me explain why that is. Right, because they multiply. This positive 1, negative 1 multiplies to negative 1, so that's good. Right, but then in order to add to the adding portion, what that's really doing is the adding portion is the outside and the inside portions of your foiling. So we should have 2 times minus 1, which is minus 2, plus 1, and that's why we're left with our minus m. So that's why this one works. Once again, it's okay to try something, mess it up, try it again, and keep playing with it so you can figure something out. A little bit bigger numbers. Okay, 5r squared minus 10r plus 7. Luckily, this 5, right, there's only one way to write that. There's no other factors besides 5 and 1 that can get you 5. So that still makes this somewhat easy. So we got 5r and r. Right, so think about it, if that was like a 24, then this could be 24 and 1, or 12 and 2, or 2 and 12, or 8 and 3, 6 and 4, like a whole bunch of different possibilities. That's where it gets really messed up. All right, now we look at multiply to positive 7, add to negative 10. Right, so that means that both are the same sign, and both have to be negative. So we got a minus for both of them. Now we just got to figure out where to put our 7 and where to put our 1. Okay, because you know that they have to multiply to 7. So one way to do it is put the 1 here and the 7 here. Well, does that work? Well, we got multiply to negative 7, that's good. But we've got negative 35, and negative 1 is negative 36. Way too big. Doesn't work. So we'll try the other way. 7 here, 1 here. Is that going to work? We've still got our positive 7, that's good. We've got negative 5, and negative 7 is negative 12. That doesn't work either. That's all the possibilities that we have. So that means this is not going to work. This is a prime polynomial. Okay, quadratic. And last problem here. Last problem is 2n squared plus 9n minus 18. Okay, this 2, we got to make sure that's in there. Luckily, once again, there's only one way to do it, 2n and n, so we can start there. Now we have to multiply to negative 18, which means we got opposite signs, and add to negative 9. Okay, so this one is a little bit tougher because there's a bunch of ways you could do this. It would be 1 and 18, 2 and 9, 6 and 3. All right, you got to figure out which is the right way to make it so they add to 9. All right, well, if I'm thinking about this, I know that 6 and 3 are probably going to be my best bet because if you, because 1 and 18 is just too big of a gap, you're never going to get to positive 9 when you're adding them, and 2 and 9, you're already at 9, so that means you're going to add or subtract 2 off of that, and that's going to mess you up too. So I'm going to try 6 and 3. Right, but where do I put which one do I put plus, which one do I put minus? Well, one way to think of it is, since the plus, it has to end up positive, that means the plus is probably going to go with the bigger number. Okay, the way to do that, so I'm going to put plus 6 here and minus 3 here. All right, once you get to here, with these types of problems, you really ought to check it and make sure it works. All right, so the way I'm going to do that, obviously I know I got my 2n squared when you do your front. All right, then you do the outside, you're going to get plus 12n. On the inside, you're going to get minus 3n. Plus 12 minus 3 ends up with plus 9. And then to finish up, negative 3 times positive 6, negative 18, that is correct. And you know you've got the right answer. Play with it.